All right, guys, everybody here? Okay. So what do you notice that's different about these compared to the equations we had been solving? Or do you even remember what we had been solving? Nope. Okay. The difference is the coefficient on the x. So you see how it's the sine of 2x or a half x, or we've got a 3x. We've got to do a little more work because it's not just a single angle. So let's walk through how we're going to do this. Maybe. First step, we are going to say let theta equal 2x. Okay, so that's going to make sine of theta equals -1. All right, can we answer that? Do we know where sine equals -1? Where does that happen? 3 pi over 2. Okay, and if I was saying all solutions, I'd say 3 pi over 2 plus 2 pi k. Remember that? Okay. All right, is theta what I'm solving for, though? No. So instead of theta, I'm going to say 2x equals 3 pi over 2 plus 2 pi k. Okay, just a substitution. That's all I've done so far. Questions? Some of you have looks that tell me you're doing stuff a little.
What do you do by letting theta equal 2x? I don't understand.
So it's just showing you, okay, I can tell you where sine of theta equals -1. And then you're replacing that back to what we have to actually solve for. It's kind of just like a step along the way to help you think back to your basic unit symbol. Because now I can solve for x. If you just leave it as 2x and like go from here and say, oh, that's 3 pi over 2, well, technically no, it doesn't equal it there. It's only if this is a single angle that it equals there. So it's just notation for the substitution here. But are you okay back to here? Like, do you see how we got back to just 2x equals that? So if I say sine of theta, just theta, equals -1, that happens when theta is 3 pi over 2. Okay? But we already established that theta isn't just theta, theta is 2x. So I can replace it so that I can actually solve for x. Because if you went right from sine of 2x to this, that's not actually a true statement. Okay? So that's why we do these substitutions in between. It's whatever here, what sine of whatever, that's what your theta is going to be. So like this one, you'd say theta is 3x. This one, you'd say theta is 1/2x. It's just whatever it's there. Okay? All right, then we have an equation with an x in it that we can solve for. How do I get the x by itself? Divide everything by 2, right? All right, so I've got x. What is 3 pi over 2 divided by 2? Good, yes. All right, you're also dividing 2 pi k by 2. So what am I left with? Pi k. Okay, that is part of our answer. If it only said all solutions, you'd be done. Okay, because that's all of them. With the k in there, you're going to keep going around the circle. That's the end. But then I also am asking you to list the solution 0 to 2 pi. So we're going to go up here. All right. Do you guys remember when you graphed and you had a b value and that changed the period of the graph? Like it happened more quickly or it happened slower, that sort of thing? Okay, we have a 2 there, so that means this is going to happen more quickly. It means you get twice the number of solutions by the time you get to 2 pi. So we're going to start with the initial one we just said, that x equals 3 pi over 4. That is one of our answers on our way from 0 to 2 pi. We have to look and see if there are other answers. You do what you just said down there. It says 3 pi over 4 plus pi, right? So I, just off to the side, have to do 3 pi over 4 plus pi. How do I add those together? Good, yeah, because this becomes 4 pi over 4, and I get 7 pi over 4. Okay. That's it, because what would happen if I added again? Like if I took that 7 pi over 4 and added 4 pi over 4. Exactly, it would be outside of this window, so it doesn't work. So we cannot do that one. So we have these two answers. Okay, so reading directions is very important. If I say all solutions, you stop with a K. If I just say 0 to 2 pi, you've got to give me the very specific angles as the answers. Okay? All right. You guys want to walk through another one together, or you want to try one? Silence. Okay. Try number 3 for me.
Crickets.
No, there's crickets. I'm going to see if I can get my technology to work. So. So you work and I'll reopen. It's whatever the equation happens to equal. So like in this case, you just say get your first couple steps up here for you guys. Just thirsty. So, always 2.k to start with. If it happens to be like, your answers are pi over 4 and pi over 4, you don't want to say both of those plus 2.k, you want to say pi over 4 plus pi. You have to think like, is that actually what you're answering? Always just use one. So very nice. We'll go see one more. We'll go through the notation. Theta equals this comma the other, or you can choose either of because that's alright guys, let's go through this one. And we'll try some more. Alright guys, so where does sine equal 1? Where does that happen? Pi over 2, okay, good. So, theta equals pi over 2 plus 2 pi k. Alright, am I solving for theta, or could I replace that with something else? 3x, yeah, so I'm going to change my theta to 3x. So how do I get the x by itself? Okay, so what's pi over 2 divided by 3?
Pi over 6.
Good. And then this is going to be 2 pi over 3k? Yeah, okay.
Yeah,
So-
divide the k by 3.
You could write it 2 pi k all over 3, that'd be fine too. Or you can write 2 pi over 3 times k, like either way is the same thing. I mean, if you really, you can't really say like 2 pi over 3 times k over 3, because that changes it. You don't need that many fractions. Alright, so that is the all solutions answer. Now let's think about our actual solutions. So the first one we know, it's pi over 6, right? Okay, what am I adding to pi over 6? It's 2 pi over 3, but to add them, what do I need to make that? Yeah, so this is really 4 pi over 6. So what's pi over 6 plus 4 pi over 6? Okay, should I add again?
Yes.
Yes, and I start with 5 pi over 6. That's what I'm adding the 4 pi over 6 to. What do I get? You could, yeah, either way. If you told me 9 pi over 6, great. If you reduced that to 3 pi over 2, great. Like, I don't care which of those. If you're getting to that answer in some version, great. That's what I want you to do. Okay. What if I tried again? What if I started with 9 pi over 6 and added 4 pi over 6 to that? What would I get? 13 pi over 6. Okay, remember we are solving from 0 to 2 pi, right? So in your head think, all right, if that's over 6, 2 pi is 12 pi over 6, right? So I need any answer up to that. So I could keep going, and then I stop. Now, to have some idea of how many answers you should have to begin with, you get one answer here, right? For sine of theta equals 1, that gave me one answer. I'm going to have 3 times that. So I should expect 3 answers in the end. So if this gave me like 2 different answers, and there was a 3 here, how many answers am I going to get at the end? 6. Yeah, okay. Does that make sense, guys? Where when it's a fraction, like I know you have the one up above that's the 1/2 x, it's not quite as clear cut as that because it just depends on where the graph is going. But if it's just a whole number coefficient, you can use that rule. Yeah.
4 pi over 6 is
2 pi over 3 the common denominator. Yeah. All right, so we don't need that one, so it is just those answers. Okay. All right. Let's go back up to number 2. I want to do this one together because it's got a couple of weird things going on in it. What's our first step with this one? What does theta have to equal? 1/2 x. Good. And then I'm thinking sine of theta equals √2 over 2. Where does that happen? First and the second quadrant, right? Like we get 2 answers for this. So pi over 4 plus 2 pi k and 3 pi over 4 plus 2 pi k. Are we okay there? Wait a second, make sure you guys are with me. All right, what do I want to replace the theta with? What does theta equal, guys? Yeah, 1/2 x. So how do I solve for x?
multiply by 2.
Yeah, multiply by 2, so let's think about that. So what's pi over 4 times 2? Okay, which is pi over 2, right? Okay. And then this is going to be plus 4 pi k, right? Okay. And then what's 3 pi over 4 going to become? 3 pi over 2 plus 4 pi k. Okay, all real, or all solutions, we stop there. Jesse? Yes. It's 1/2 times x, so you could divide by 1/2, which is the same as multiplying by 2. You're just trying to think about how to get rid of whatever's with the x. Okay. Are we okay to the all solutions step? Okay, so then we got to go up here and think about our actual answers. I know my first one is pi over 2. Is that in the window 0 to 2 pi? Yeah. What do you think? Should I add 4 pi to that? That's going to be too big, right? Okay, so we don't add. So my next option is 3 pi over 2. Is that in my window that I can use? Yeah. Should I add 4 pi to that? Okay, so that's it. You got those 2 answers and you're done. It's whatever you tell me to add in this step. But does adding 4 pi make any sense? If we're trying to solve between 0 and 2 pi, adding 4 pi is definitely going to be too much, right? So there's no point in adding it and checking to see if it's too big. Like, you know already it's going to be too big. Okay? So that's why it ends up just being this one and this one. And there's going to be times when you go through and you're like, okay, this one is in 0 to 2 pi, and this one might not be. You might be like, well, that's already bigger, so you still can't include that as an answer.
So, on their own, they still fit in.
Yeah, so since both of these are within 0 to 2 pi, we have both of those as an answer. Okay. All right, let's try again together. One more together, and then I'll have you try. Actually, I changed my mind. I want you to try 4 and 6 on your own, and I'm going to change question 5 for us. you guys do 4 and 6? And then we'll come back to 5 together. So I'll give you a minute here. 4 and 6. Talk to each other. Okay. Questions? Okay, so right, like, you have those two so those are your all oh, it doesn't matter. Yeah, it can be things like and the period would change when you go through the census. Sometimes they will So guys, again, 4 and 6, you can jot down 5. We'll go through it together. So I would change the question for 5 just because it's different. I would still do so is tangent equals negative 3. So another minute here, finish up 4 and 6, remember? Guys, while you're working, I'm just going to pass out for you a February calendar and your quarter 3 standards tracker. I still have 2 more. Hopefully just somewhere if you guys. It is to help you not lose it, and it's bright orange. It is very bright. No, February on Saturday. How did that happen? Right? Yeah, for all our music, right? Reminder, this matters. On card stack. All right, I'm going to go through 4 and 6 up here so we can see those. All right, guys, number 4, check your all solutions answer first. Because if you mess that one up, you're going to mess up the other one. Did you leave it as 4 pi over 6 instead of changing it to 2 pi over 3? Or yes, Jesse.
5 pi over 6 and 7.
As like the initial places,
As the initial.
like here.
Yeah.
So its sign is negative, so that's going to happen in the 3rd and 4th quadrant.
Oh, I did it.
You did it as cosine. And those would be right for cosine. It is sine. So, because if I'm dividing by, that's a 3. Multiplying by 1/2, right?
Oh.
Okay. I know, fun with fractions. Right? Okay, guys, from there then, my actual answers. So I had 2 answers initially. How many answers do you expect to get at the end? 4. Why is it 4? Because there's 2 and 2, and 2 times 2 is 4. Okay? All right, you're going to get twice as many answers. So the first one's going to be 2 pi over 3. What am I adding to 2 pi over 3? Pi. What do I get when I add pi to 2 pi over 3? 5 pi over 3. I'm taking 2 pi over 3, right, the initial answer,
Yeah.
and I'm adding pi to it,
Yeah.
which is really 3 pi over 3. It's not 1. Yeah, okay, so we get 5 pi over 3. All right, I can't add again to that answer, so I have to move on to the other one, which is 5 pi over 6. I'm adding pi again. What do I get when I add pi to that? 11 pi over 6, good. So there are your 4 answers. And guys, those 4 are all things like that we know from our unit circle, but they don't have to be, okay? The answers you get might be really weird. You might have, 9 pi over 20. Like, it doesn't matter what the answers are. They can be strange things that you don't normally see, okay? All right, issues on 4. Okay, let's go through 6. Theta equals 3. All right, tangent equals -1 in 2 places. It's at 3 pi over 4. And what, 7 pi over 4? Not talking about theta though, talking about 3x. So when I divide by 3, everybody okay with me just reducing that to pi over 4? I think we understand what's happening there, okay. Plus 2 pi over 3k, 7 pi over 12. So those are your all solutions. If you left it as 3 pi over 12 for the first one, it's fine. Like, that's still the same thing. Okay. All right. How many answers am I going to end up with on this one? 6. Yes. Joy. Right. Okay, first one's pi over 4. Off to the side here, pi over 4. You are adding to that 2 pi over 3. How do I add those two fractions? 12s, yes. So this one's going to be 3 pi over 12, and this is going to be what, 8 pi over 12? Okay, so what do I get? 11 pi over 12. What am I adding to that, guys? Yeah, don't go back to the original. You've already found the common denominator, so just add the 8 pi over 12 again. So what do I get when I add 19 pi over 12? Should I add again or move on to the other answer? Move on, okay? So I'm going to have 7 pi over 12. Make sure you guys can see this. 7 pi over 12. What am I adding to that? 2 pi over 3, which if I want a common denominator, what's it really going to be? 8 pi over 12. So what do I get? 15 pi over 12. You could reduce that. You don't have to. Add again. What do I get? 23 pi over 12. So again, weird answers, right? But totally fine. Yeah, but to 2 pi. So I always think initially 2 pi. Okay, I want that to be something over 12. Right?
So it's always over 12?
It's over whatever these are over. Okay? So that you can make the comparison. It's just a different way of writing the exact same value so that you can actually decide what's bigger or not. So I would know if I got to like 25 pi over 12, that's too big.
So just to clarify, it's like you take the first answer you got, add it to the answer. It's not like you take the first one and take the second one.
Right. Take the first one, add until you can't add anymore. Take the second one, add. So if there were like 4 answers to begin with, joy, yeah, you have a lot to add. All right, are we getting it, guys? Okay, good. So let's look at number 5. Did you guys have a chance to jot this down, the one I changed? I changed number 5. 2 cosine squared plus sine x minus 1. And this really isn't too bad. This is more like 26 day 1, but I just want to make sure you understand what we're doing. All right, anybody see an issue with this? Yeah, what do you see? There is both cosine and sine. That's not going to work very well for factoring or anything like that. So I don't want there to be both cosine and sine. So what could I replace cosine squared with so that there's no more?
1 sine squared.
1 minus sine squared. Okay, back to those Pythagorean identities. And then it's plus sine of x minus 1 equals 0. Yes, you need the parentheses, okay? They matter because it's 2 times that entire thing. All right, so just a little bit of simplifying here. I would distribute the 2. So we'll have 2 minus 2 sine squared x plus sine of x minus 1. We'll combine some like terms here. So negative 2 sine squared x plus sine of x. And then are you guys okay with plus 1 equals 0? What's 2 minus 1? I just combined these 2.
Oh, you just didn't do that in front.
Yeah, I put it in the normal order for factoring. Yeah, your standard form there. Okay, when I factor, I don't like it when the leading term is negative. I just think it's harder. Okay, so how could I make it not be negative? Yeah, change all your signs. So this is 2 sine squared x minus sine of x minus 1 equals 0. Okay, we are factoring. Can you do it without a box and a circle and all that stuff? No. Okay, I'll give you a minute then. All right, guys, I look at it and think, okay, the only way I can get 2 sine squared is a 2 sine of x times the sine of x. Okay, the only way to get -1 is 1 times -1. You just have to figure out which one goes where. I'm going to do +1 - 1. How do I know? Like, how did I know that's where the positive one went and where the negative one went? What is the check part of the guess and check? Like, what do I mean by that? Do you guys know? Or you're just like, I don't know, you just say guess and check all the time. Susan, what are you going to say?
Multiply the one by the singular sign, but the non-singular sign just
You're like multiplying it out in your head, right? Yeah, guys, remember when if you called it FOIL, you do those two, and then those two, and those two, and those two, right? Let's see if I can make it noticeable. What determines that middle term is 2 sine times -1 and 1 times sine. Because those are the two you're going to combine to get that middle term. So you should just be checking that in your head. If you're like, all right, so that's -2 sine plus 1 sine. Yep, that gives me the term that I want. If it doesn't, try switching the values, okay? Yeah.
How do you, where do you get the positive one from?
So if I were to multiply this out, to get this last term here, right, I need to multiply 2 numbers together.
Yeah, but like, I'm talking about when you have the, oh wait, never mind. Okay.
You're talking about the factoring or up above?
Okay, never mind. All right.
Are you sure?
Yeah.
Okay.
I just misread something.
Okay.
That 2 looked a little, the thing under it looked a little bit like a 3, and I got confused.
Oh, it does look like a 3. Great. All right, guys. So from here, again, this is back to what we were doing on day 1. What do I do with each of these factors once I get to the factor? Yeah, separate them, set them equal to 0. Remember, this is where you have to have a 0 on one side of your equation. So I'm really looking for where does sine equal -1/2 and where does sine equal 1. What do you want to tell me? Where's sine equal to -1/2? 7 pi over 6, yes. And 11 pi over 6. And where does sine equal 1? Good. Now, again, depending on the directions, if it said solve from 0 to 2 pi, there are your 3 answers. What if it said all solutions? Yep. So please, please, please read directions. Okay? So again, depending on what the directions say. Okay. That's the end of 26 day 2. So homework, if you turn the page, it is just, I think it's somewhere in the next page there. Yes, lovely. What? It's 8 problems, and look at question 1. Hey, we just did that one, okay? So really, you have to do 2 through 8. Okay, so you have 7 problems to do there. All right, we also today have to get through at least most of standard 27. So guys, did you happen to bring your calculators today? Okay, if you have a calculator, get it out. If you don't,